We're working in section 5.2. We've been using the Gauss-Jordan method to solve a system of linear equations. In the previous examples, we had two equations in two variables, and now we have an example where we have three equations in three variables. And so it's worth pointing out here at the beginning that we want diagonal form, and diagonal form for a 3 by 3 matrix will look like this. So three equations in three variables. The diagonal from top left to bottom right is 1s, and then 0 everywhere else on the left side. And then on the right side, three constants A, B, and C that represent the answer, the solution to the system. So let's go ahead and get right into it. Let's write our system of equations in matrix form. Just take the coefficients and the constant and write them out. So 1, -1, 5, and -6. Just like always, we use brackets on the matrix, and we use a vertical line where the equal sign was. 3, 3, -1, 10, 1, 3, 2, 5. Okay, so we want to go ahead and convert this to diagonal form. How do we do it? We go column by column from left to right. We start in the first column and we put a 1 on the diagonal, and sure enough it's already there. So that's convenient, and that means that we can go on to the next step. What's the next step? The next step is to find zeros everywhere else, is to make zeros everywhere else in that first column. So the first row will stay the same, and for the second row we want to turn this 3 to a 0. So how do we do it? We're going to multiply the first row where we have the 1 on the diagonal. We're going to multiply that row by the opposite of this number, and then we're going to add the two rows together. So -3 times row 2, times row 1 plus row 2. And then let's go ahead and write out the step for the third row as well. So for the third row, we want to put a 0 where this 1 is, and so we're going to multiply the first row by the opposite of this number and then add the rows together. That's -1 times row 1 plus row 3. So it's a lot, and so we just want to be careful as we're going through that we keep track of everything. Maybe for this first step, I'll just go ahead and write out exactly what we're doing. So -3 times the entry in row 1 plus the entry in row 2. -3 times 1 plus 3 is equal to the 0 that we're trying to make. And then -3 times -1 plus 3 is equal to 6. And then -3 times 5 plus -1 times 5 plus -1 is -16. And -3 times -6 plus 10 is equal to 18 plus 10 is 28. So that gets us the second row. And then we can do all this again to get the third row. So multiply the first row, multiply the entry in the first row by -1, and then add it to the entry in the third row. So -1 times 1 plus 1 makes the 0 that we're trying to get. And then -1 times -1 plus 3 is 4. And then -1 times 5 plus 2 is -3. And then -1 times -6 plus 5 is 11. Okay, looks good. And so we finished the first column and we're ready to go to the second column. How do we begin? We make a 1 on the diagonal. What number is on the diagonal right now in the second column? It's this 6. How do we make it into a 1? We multiply the entire row by 1/6. 1/6 times row 2. Let's just copy down the first row. And then when we multiply, we get 0, 1. -16 times 1/6 is -16/6, or -8/3. And then 28/6 is 14/3. Again, lots of work with fractions. We'll leave the third row alone. And things are looking good. The first column is finished. In the second column, we have a 1 on the diagonal. And now we're going to make zeros everywhere else in that second column. So how are we going to do that? In the first row, we want to change the -1 to 0. So we're going to multiply row 2 by +1. I think I said it right, but wrote it down incorrectly. So we're going to multiply row 2 times +1 and then add it to row 1. Okay, the second row will stay the same, and then for the third row, we'll multiply the second row by the opposite of this number. So that's -4 times row 2 plus row 3. Okay, so let's give it a go. You know, we've already finished this first column, so we don't really need to worry about changing it into something else. It won't change into something else as long as we're doing the steps correctly. So we know that the first column is going to start with a 1, and then the second column, we know that we're making a 0, so we don't have to worry too much about that as long as we've done our step correctly. We're just adding row 2 plus row 1 together. In the third column, -8/3 plus 5 might be worth writing out to the side. So 5 is the same as 15/3 plus -8/3 is +7/3. So there we have it. And then we also have 14/3 plus -6 or -6. So that's going to be 14/3 minus 18/3 is -4/3. And we can write that one in as well. Okay, the second row stays the same, 0, 1, -8/3, 14/3. And then in the third row, 0 will stay the same. We're making a 0 there in the second column. And then in the third column, we have -4 times -8/3 plus -3. So this is 32/3 minus 9/3, which is 23/3. And then we have, in that last column, we have -4 times 14/3 plus 11. So be careful here. That should be -56/3 plus 33/3. -56 plus 33/3, which is -23/3, which is nice because that means that will come out to an integer value in the next step. If you don't see that yet, bear with me just a moment and I'll show you. Okay, so there's a good looking matrix. The first and second columns are both finished, and we're going on to the third column. And we always start with the row on the diagonal. That's this third row. This 23 over 3 needs to become a 1. And so how do you do that? Multiply that row by the reciprocal of this number. So 3 over 23 times row 3 will give us 0, 0, 1, and then negative 1. 3 over 23 times negative 23 thirds in that last column gives us negative 1, and so we know the value of z is negative 1. We can just go ahead and copy down the other rows and then go on to the next step. Okay, so we have 1 on the diagonal. Here we'll finish the problem. We'll go ahead and get zeros off of the diagonal in the third column. So specifically, this 7/3 means that we need to multiply the third row by negative 7/3. Negative 7/3 times row 3 plus row 1 will be the new row 1. And then in the second row, negative 8/3 means we need to multiply the third row by positive 8/3. Positive 8/3 times row 3 plus row 2. And then the last row will stay the same. So let's go ahead and do it. We know the first 3 columns already, and for that matter, it might be nice just to go ahead and write them in for all of the rows. This is what we're working toward. And in the last row, in the last column, we have the negative 1. We need to get the entries above it. We need to do negative 7/3 times row 3 plus row 1. So that would be negative 7/3 times the entry in row 3 plus the entry in row 1, which is negative 4/3. And so that's 7/3 minus 4/3 is 3/3, which is just 1. And then we also need to do 8/3 times the entry in row 3, which is negative 1, plus the entry in row 2, which is 14/3. So this is negative 8/3 plus 14/3 is 6/3, or 2. And so there we have it. Now, I went kind of fast through the first 3 columns here in this matrix. I hope that you understand how we know what these first 3 columns are going to look like. And then I hope you'll take the time to do the calculations here to verify that the numbers really do come out the way we wrote them in the first 3 columns. And then, of course, we showed the work in the 4th column. Okay, it's time to write our answer. And the first row of the matrix just says x equals 1. And the second row of the matrix just says y equals 2. And the third row says z equals negative 1. So we can box that up. We can also write it as an ordered triple, 1, 2, negative 1. And we finish the problem. I think it's worthwhile for us to go back and just look through these steps one more time before we finish the video. It seems like there was a lot there. You remember where we started? A system of 3 equations and 3 variables. We know the diagonal form that we're going for. And so here we begin with the matrix form of the system. And then we said, that's nice, we already have a 1 on the diagonal. So then we made zeros off of the diagonal. This is all in the first column. First column's done. Go to the next column. Go to the second column. We made a 1 on the diagonal, and then we made zeros off of the diagonal. So 2 more steps to get the second column finished. And then we repeated that process one more time in the third column. Here we are with the first 2 columns finished. In the third column, a 1 on the diagonal, and then zeros off of the diagonal. It's a lot to keep up with. It's a little bit abstract. And so this can be a confusing problem for some students. And so you just want to take your time to go through the steps and to practice with the homework, and I bet you'll get it.